Hey everyone, welcome back to the channel. And in our previous video, we covered what linear regression is and how businesses use it for predictions. Today, we're going to see exactly how linear regression works by using real data. I've prepared a data set of 7 used cars that we'll analyze together step by step. Before we start, if you're new here and learning data science, please subscribe to the channel. It helps us grow together and supports more educational content like this. Let's dive into our car price prediction example with actual data. Here's what we're working with today. As you can see on the screen, I have data for 7 used cars. Now, let's plot this data on a graph to visualize the relationship. Watch as I place each car on our coordinate system. The horizontal axis represents car age in years, and the vertical axis shows the price in thousands of dollars. Let's plot our first point. The 1-year-old car that sold for $25,000 goes here. Next, the 2-year-old car at $22,000. The 3-year-old at $20,000. As you can see, we're getting a pattern here. Each point is moving down and to the right. Continuing with our 4-year-old car at $18,000, the 5-year-old at $16,000, the 6-year-old at $14,000, and finally, our 7-year-old car at $12,000. Look at this. All our points are forming a clear downward trend. You can almost imagine drawing a straight line through these points. This is exactly what linear regression does. It finds the best straight line that fits through all these scattered data points. Now, let me draw what linear regression considers the best fit line. Watch as I add this line to our graph. See how this line passes very close to all our data points? Some points are slightly above the line, some slightly below, but overall it captures the trend perfectly. Let's understand what makes this the best line. Linear regression measures the distance from each actual data point to the line. These distances represent prediction errors. For example, look at our 3-year-old car. It actually sold for $20,000, but our line predicts about $19,800. That's a small error of $200. The algorithm finds the line that minimizes the total of all these squared errors. This is called the least squares method. In machine learning, this method is known as ordinary least squares. What we do is take the errors, the differences between the predicted values and the actual values, square them, and then sum them all up. This total is what we call the SSE, or sum of squared errors. When we plot the best fit line, our goal is to minimize this SSE to find the line that keeps these squared errors as small as possible. I will simplify this again. While plotting the best fit line, we basically try to minimize the sum of squared error, which is SSE. Now, let's examine our line more closely. Every straight line has 2 important characteristics: slope and intercept. Looking at our line, I can see that for every 1-year increase in age, the price decreases by approximately $2,000. This is our slope, negative $2,000 per year. To find the intercept, I need to see where this line would cross the vertical axis at age 0. If I extend our line backward, it intersects at approximately $27,000. This represents the theoretical price of a brand new car. So our linear regression formula becomes price equals $27,000 minus 2,000 times the car's age. Let's test this formula with our data. For a 4-year-old car, 27,000 minus 2,000 times 4 equals 19,000. Our actual data shows 18,000, so we're very close. For a 6-year-old car, 27,000 minus 2,000 times 6 equals 15,000. Our actual data show 14,000. Again, very close to our prediction. This demonstrates how linear regression creates a mathematical model that can predict prices for cars we haven't even seen before. Let's say someone brings us an 8-year-old car. Using our formula, 27,000 minus 2,000 times 8 equals $11,000. That would be our predicted price. What's remarkable is that this entire process, finding the best line, calculating the slope and intercept, happens automatically in milliseconds when you run linear regression algorithms. The algorithm tested millions of possible lines and determined that our line with a slope of negative 2,000 and intercept of 27,000 gives us the smallest total error across all our data points. The same approach works for any business problem where you have 2 variables with a linear relationship. The process remains exactly the same, whether you're predicting sales from advertising spend, website traffic from marketing investment, or any other business metric. Linear regression also provides confidence measures for each prediction. Some predictions will be more reliable than others, which is valuable information for making business decisions. In our next video, we'll extend this concept to multiple linear regression. Instead of just considering car age, we'll include multiple factors like mileage, brand, and condition to make even more accurate predictions. If this step-by-step walkthrough helped you understand how linear regression works, please subscribe to the channel. It really supports the creation of more educational content like this. Leave a comment and let me know which part of seeing the actual data plotted made the concept clearer for you. Was it visualizing the line of best fit or calculating the slope and intercept? Your feedback helps me improve future videos. Thanks for watching.